this gem basically called GitHub auth. And what it allows me to do is if I just gem install, you guys might want to try this as well just for fun. If you go gem install GitHub auth, it'll install a gem, and this gem lets you actually add other people's SSH keys to your authorized keys file. Like so, after you've got it installed, you can go gh-auth, and then add the user that you want to actually install on your machine. So I know you're S. Peasley and Lu Diong. So as soon as I type GitHub auth, whoops, S. Peasley, Lu Yong, it'll actually try to go find those users from GitHub, pull their public SSH keys, and try to install into the authorized keys file. Yeah. Add. So you go gh-auth add and then the name of the user. So my username on GitHub is Mocon. That's right. And then once you've done that, you should go to your your .ssh folder. There'll be a file in there called authorized keys. And if you just go cat that file, you'll now see my GitHub SSH public keys are in your authorized keys file. Right? And I just did this for you guys, so you guys both have SSH access to my machine now. Right? So what'll happen? The command. Here. I'll tell you what. Why don't we do this? Why don't you guys just SSH into my machine, and then I'll show you. So if you could both, in the chat window, there should be a command there. Can you see that, Stephen? It's like, there's the link. Okay, here, let me just copy this in again. So if you could just type, I prefer if you didn't announce it, because I am recording this. But this is like the port that I use for SSH. So if you actually take that command and type it into your terminal, it will then try to SSH into my machine that I'm on right now on that specific port using that user account. And because your public keys have now been added to my authorized keys file, as long as you're using the same keys, you should be able to SSH in. So do you see the command? Yep. And if you type the command, what do you get? Okay. Yeah. I see two people on my system now. Okay, so now what I'm going to do, so that we can all like share the same session, because right now we all have independent sessions. We can't actually see what everyone else is doing. So right now you have access to my machine. You can do whatever you want. But for us to be able to see the same session, I want to use something called tmux. So I'm going to start a new tmux session. This is a terminal multiplexer. And I'm going to start a session, and I'd like you guys to attach to my session. So if you guys just type tmux space AT. No, you're not, because you're on my machine. So just type tmux space AT. Are you on? And you should say attaching, like I should attach to a new tmux session. There we go, I know someone's attached. tmux space AT. Ha, look at that, see? So I can see what you're typing. Isn't this awesome? Okay, so that was you, Steven, typing, right? Lou, where are you? Say hi. Lou Tang. Nice. Okay. That's awesome. So this now we're both, all three of us have entered into, well, actually, the two of you have SSH'd or started an SSH session onto my machine. I'm just running it. I'm on my machine with my own session. I'm not going through SSH or anything. We're using tmux to all basically connect to the same tmux session, and now we're sharing a session. So we can see what everyone's doing. So if I go back, you'll see I've got some changes to my authorized keys file. So what I did before you guys SSH'd on is let's see if I can find my history. Oops, gem install GitHub auth. As soon as after I did that, I did GitHub auth add users S. Peasley and Liu Yong. So that went to GitHub's API, pulled down your public keys, and then installed them into my authorized keys file. So if I go look at my authorized keys file, actually let's do this. We go at the very end, you'll see I have your public keys, right? So Stephen, you've got a few public keys, it looks like, on GitHub. Lou, you've got 3 or 4 as well. So it took all of your public keys and added them all. So whichever one you chose to authenticate with, they all ended up in here. So you were able to get into my machine, and that's kind of like wicked to me. I don't know. Okay, so that's all I got on that. What are we going to talk about today? I don't know. Yeah, so yesterday's video I sent out talked a little bit about this authorized keys file, but I didn't really talk about how you could actually pair program using this, right? Let's go to GitHub, Mocon. Should have a Ruby bootcamp. What is this? Bootcamp. And hello Rails. All right. Oops. Yeah, let's do that. Upgrade to 2.1.1. And bundle check. Let's see some gems. This, I guess, the beauty of this setup is it allows us to all work virtually, and well, the one thing that sucks about it is you'll have to use the same editor, right? So unless you're all well versed in Vim, it doesn't quite work, but you can all see what's going on. Yeah, we were going to talk about Linux, the file system, right? I don't really have a set plan. I already covered what I was going to cover, so that's all. Okay. Okay, let's do that. Where should we start? Well, let's start at the very beginning. Okay, I'm going to kill this. Let's go to the top level directory in the file system. If we just do an ls at the very root of the directory, you can see, let's do this. The very root of the directory, there's a few top level directories that are interesting. Bin, dev, etc, home, lib64, media, mount. Every Unix distro or Linux distro has a slightly different variant of this file system. But at the very root of the file system, most of them have this bin directory. So if we go to the bin directory, what that is like a set of binaries or executables that are basically available everywhere. So you can see bash is in there, right? So when I start a new bash session, it's just loading it from that bin directory. Kill, what else do we have? Cat, these are all binaries that typically ship with your Unix distro, and this is where it's loaded from. If we just do an ls-al and bash, we can get the info. You can see that it's got read, write, execute permissions for myself, and then execute and read, write, execute for myself, read and execute for the group, and read and execute for everyone. So everyone's got at least read, execute on that file, and that's available to everyone on the file system. So if we go back up, next is let's take a look at the etc directory. Typically, there's most of your configuration will be in the etc directory. So this is where, when you install a program through sudo apt-get blah. Let's see, we go sudo apt-get install nginx. I think I've got MySQL. Do I have nginx in here? I don't. We got MySQL, but this is where the MySQL configuration files will typically go. So let's go look in that directory. Let's see, there's a conf. So conf is typically the convention, or conf.d, the convention for where you put your configuration files for that particular package. So when I did a sudo apt-get install MySQL server at some point, it installed these base template configuration files. So if I just open up my.conf, you'll see this is the default port that it's running on. This is basically the configuration for the MySQL server on my particular machine, right? And you can actually configure that further. to your pleasure using this directory structure. Going back up, so that's sort of like, so bin is where you put your like binaries and executables like that ship with the Unix distro. Then there's also like the executables that you want to install yourself, right? So we saw that the configuration files for those typically go in Etsy. So if you saw MySQL, this is where all the configuration is, but there's no binary for MySQL in here. MySQL, I'm not sure where's MySQL is actually installed. It's installed in user bin. So if we go back up to user, this is, I think, where the binaries that you install get installed to. So user bin, we should be able to see the MySQL as well as anything else that I've installed. So G++, Python, yeah. And then if we go rep for MySQL, it should be in there. Let's just pick on MySQL. Is there a server? Show? No. Let's do this. We'll go into here. And let's just do an ls, whoops, al on MySQL. Let's just do the base binary. So you can see that's actually got read, write, execute as well. So this is an executable. It's got the asterisk on the far end, meaning it's a binary or an executable program that you can actually run. And that's MySQL itself. So very top level, bin, that's sort of the binaries that ship with your Unix distro. Etsy, that's typically where configuration goes for the binaries that you install. So in our case, we're talking about MySQL. User bin is typically where your binaries that you install go into. And then there should be a, oops, let's go back to the top. Oops, I'm going to go up to here. Next up is let's talk about the home directory. So every account that you create on the system typically has its own directory, and that'll be under the /home. So if you go under /home, you'll see I've got an account for Mo, and that's the only account I have on this machine. And that is my home directory. So when I type cd tilde, that's actually just taking me to my home directory, home/Mo. And if I were to switch accounts, if I had another account on here, then if I switched account and cd to the home directory, that would take me to home/Mo. I don't have a root account on here, but actually, everyone does actually. So if we go back up to the top, you'll see there's this folder root. It's permission denied, but let's see if I can just sudo as root. So you'll see now I'm actually the root account, and my home directory. Root's kind of special. Its home directory isn't in home. I think it just differs based on the different Linux distros, but from the ones that I've seen, root is typically at the very top directory. So the root account's home directory is typically /root, but for all other accounts are typically in /home/root. This is Ubuntu 12.04. Okay, so let's just get out of here. I don't want to be root. Let's go up to the top level. We talked about bin, dev. Let's take a look what's in devs. What is dev? Dev is, I guess, this is like all the devices on your machine. So everything in Unix is typically a file. So the way you would even access RAM would be like very similar to a file. So these are like where you'd find the files to connect to your memory, your CD-ROM, your disk drives, all the terminal, I forget what they're called, RAM. There's dev null. So typically when you're like typing, yes. So if I'm echoing a command or some shell script like hi, typical pattern you'll see is to just redirect it to dev null. And so that's the null device. Basically, it's a file descriptor that goes to nothing. Right? So if you just want to basically write I/O to a null device, you would go to that. I don't really know how to interface with the devices very well, but you'll see and then there's also standard error, standard ins, and standard out. So those are the three file descriptors that start it with every process, right? So standard in is typically file descriptor 0, and then standard out is file descriptor 1, and standard error is file descriptor 2. So if you ever see a command like redirect ampersand 1 to ampersand 2, I can't remember the exact syntax, I have to look it up. what that's actually saying is like redirect file descriptor 2 to file descriptor 1, and file descriptor 2 is standard error, so it's saying redirect all your standard error output to your standard out output, which means if you're redirecting standard out to a log file, it'll just put all your errors and all your typical like logging into the same file, as opposed to two separate streams, right? Okay. If we go back up, so that was dev. We talked about bin, dev, lib64. So those are like the shared libraries for the 64-bit shared libraries, and then lib are just the 32-bit shared libraries. So if we go into there, we should see a bunch of like .so files. So those are like shared objects. They're typically like you take your C binaries and compile them down to SO files, and then you link to those SO files from your programs. So let's see if we can find a good example in here. To pick on. Resolve conf. Let's go into resolve. I don't want that. Well, let's say I had a program I was building and I wanted to depend on a system library. I could actually just like link to one of those shared object files. So in like the Microsoft ecosystem, they'd be like similar to like DLLs. These are shared libraries that you can like link to across your different programs and connect to, I guess, system APIs. And then if we go back up to lib64, these are the 64-bit versions. So in this case, looks like I only have one 64-bit shared object file. This is pretty fresh machine, so I don't have a whole lot on here. Lib64 mounts. These are the different mount points on your machine. Oops. So here, I don't have anything mounted, but if you typically like mounted a second drive or a second device, you could put like a mount point in here, and then when you wanted to actually connect to that mount, you would just go to /mount/ whatever that device name is. For me, I have an external drive that I mount in the media folder. So you can see I've got media/data. So that's like a second drive that I have that's just mounted at that point. And then right now it looks like I have a USB disk drive connected at 4788. Proc. So this proc is sort of tells us about like the information about our system. So if I wanted to know, let's see, cat file systems, this gives me some basic information about my file system, the different file systems that it supports. The typical one you'll see is like processors. Where the heck is that? Yeah, well, more like, I think it's called System Manager, where you can see how much CPU you have, how much memory you have, what is your swap space, what's your uptime, if we just cat uptime. That, I don't know if that's the Unix epoch. Yeah, I think this is more or less like system information. Not quite sure. Okay. So that's proc. sbin. I don't know what sbin is. I think this is like, it looks like another folder where you could put other binaries. I don't know when you would choose to put binaries in here versus, I think when you typically sudo apt-get install, it usually goes into user bin. These binaries look like they manage, yeah. No, I can't actually see what's in it. Ah! Oh, that's okay, we'll just start a new session. Can you see that? It could be, I don't know. Let's see, well, we've got fdisk in there, fsck, so these are, looks like these are utility programs. So when you want to manage like repartitioning, changing the swap size, starting daemons, so these, getty also, yeah. Okay, and let's see what else. Oh, I didn't see that. Yeah, I'm not sure why you choose to put ifconfig in here versus in the bin directory. Yeah, I guess the thing that trips me up is like, why would you put? How would you decide what to put into sbin versus bin, right? Because in bin we've got programs like bash. I guess these are more like Unix utilities that are you would expect every Unix system to have. And then sbin are programs that are specific to this distro, perhaps. Like ifconfig may not be available on every Unix variant. Yeah. All right, let's take a look. Next, sbin sys. I don't know what sys is. What's sys? Block, power, kernel, firmware, devices. This looks like system information. Debug, profiling. Let's see what's in profiling. It's like you can read from it, so let's just take the head from profiling. Looks okay. And there's nothing in it. Okay. So I'm not sure what this directory is either. Let's go back up. Sys var. Okay, var is more interesting. Var is typically where you find your logs, your backup, cache, and I guess this is where your mail would go as well. If we go into the log directory, we should be able to see the different log files that your system typically records. This is usually the first place you'd look when there's something wrong. So if you're trying to understand why MySQL is not starting up, or why RabbitMQ's blowing up in your face, or why the Nginx access logs will typically be in here. If you need to find a log, it'll usually be in here. This is typically the dump for all logs and log files. And then of course there is mail, which is what the mail program manages. Opt. I don't know what opt is, but apparently Adobe Air wants to install into there, so this might be. I don't know what opt is. It's interesting that Adobe is the only one that installed anything in here. Okay. And then, so let's go back up here. And then the temp directory, CD-ROM. Yeah, I think I covered most of it now. Opt, run, serve, user. The temp directory is just used for temporary files that your system's constantly churning. These can typically be wiped out. You can see that I've got all my Vim files writing to this temp directory here. Right. Permissions, sure. Let's go to, what's a good place for that? Why don't we start with bin? And we can just check the permissions on bash. We kind of did that really quickly, I think. Yeah, so we can see that bash is the first three here represent the user. So read, write, execute. My user account's got read, write, execute. The group that I'm in has read and execute, and then everyone in the system has read, execute. So at a bare minimum, everyone's got read and execute permissions on bash. So anyone who's on the system can actually execute bash and therefore start a bash session. If I were to actually do this on a directory, so let's go back up. So go ls-al on the bin directory. Oops. Let's try this again. You'll see bin has, instead of a hyphen, it's got a D at the front, indicating that it's actually a directory and not a file. And then I've got read, write, execute. My group's got read, write, or read, execute, and then everyone's got read and execute from bin. This you can see is a symbolic link. So this is a link. The file appears as init rd.amg, but it's actually pointing at this particular file on the file system. Yeah. And then actual files, like we just saw, have a hyphen instead of a D. Let's go to my home directory. See if we can find interesting. You can see that this file here apparently belongs to the root account. This file here belongs to my account. and these are the permissions that Mo has. So when we're talking about the first three positions in this, like exclude the first one. So the first one just indicates what type of file it is, whether it's a directory, a symbolic link. The next three indicate what the user who owns the file, what their permissions are. So because Mo owns the file, his permissions are read, write, and there's no execute on there. Yeah, so user, group, and then other. Does that answer? Let's go look, change mod. So change mod to change the file mode of the bits. So you can add or remove a permission from a specific file using this. So if I wanted to, let's say, well, let's do this. So I'll just go into my own bin directory. So this is the bin directory in my home folder. You can see I've got a few basically executable files that I have in my bin directory in my path. So if I look at my path here, you can see that I'm exporting my home directory. Where's my home directory? There we go. I'm exporting my home directory's bin folder into my path. So whenever I type a command, the command, it looks in the path to see if it finds a binary in that path, right? And it's always going to go from the very beginning to the next folder, right? So if I type blah, it's going to check home bin to see if there's a file that's executable called blah in that directory. If it's not, then it's going to go to the next directory. And if it's not, then it's going to go to the next directory, right? And if it's not, then it'll just go to the next directory. So like by default, your system will start up with a bunch of stuff in path already, right? So these are all the folders that we looked at earlier, like all the user /bin /sbin. Those are all those folders that contain binaries are pretty much by default added to your path, right? On top of that, we just saw that I added my own home directories bin folder. So this is my own convention where if I want to put my own binaries that I'm writing, I'll put into my home directory. Yeah. And then it gets loaded in. So in here, there's a couple files. So let's just create our own. So we'll just start a blah.sh file. I'm going to say that this should run down shebang. Let's just go bin bash. And I want it to just go cow say hi. Okay. So if I just run this file right now, if I try to okay, let's just look at the permissions on this file right now. By default, the permissions, it's got read, write, execute automatically. So that wasn't what I intended, but let's go okay, so right now, if I were to execute this, it does exactly what I want, right? It knows that it's got execute permission, so I have no problem. If I had gone to a different directory, so let's try to do this again, we'll go vi let's just leave it as and go say that shebang should be / how does the pang user bin user bin bash, we'll say cow say blah or If I save this now, we'll see that this file actually has also read write. Why is everything read write execute? Okay, this isn't making sense to me. It could be, but by default I expect it to just be read permission. So if I go change mod, now I'm going to actually remove the execute bit from that file. So I'm going to remove execute from blah.sh. If I go ls-al on it now, I'll see it's just got read write, right? And then I can re-add the execute permission or execute bit onto that by just going +x blah.sh. And as soon as I do that, it's marked as an executable, so I can just run it like any other executable. The / says in this directory, I want you to run this file, right? Now if I go back to here, I'm no longer in my bin directory. I should be able to just type blah, and it didn't find it. Why didn't it find it? There we go. Sorry, I had to give it the full name, blah.sh, right? So if I go to bin, let's just move blah.sh to blah, and I go to, let's just go to some random directory, and then I type blah. There we go. I now have my blah command, right? So the order of execution is I type blah, it then goes and looks in my path, right? So if I type $path, it's going to look in my path, right? Starting at this directory, it's going to be like, hey, is there a file that's marked as executable in this folder called home/mo/bin called blah? In fact, there is. So I found the file I'm looking for, and it'll execute that. Now, if I have a blah in home/mo/bin, as well as let's say I've got a blah in, I don't know. Why do I have my path duplicated? That's interesting. If I had like blah defined in two different paths, right, in two different folders, but it found it in this folder first, that's the version that it's going to execute, right? And then the version in the other folder is just going to be ignored because it's just going to find the first hit and use that. There's no reason for it to run all of them, right? So if you're trying to execute a program that seems to be running a different, like the wrong version, an example of that is like ctag. So Unix typically ships with like a GNU version of ctags, but I typically use exuberant ctags, right? So I have to make sure that my version of exuberant ctags gets loaded into my path before the one that typically ships with Unix distros, which is the GNU ctags, right? Right, I put my home directory binaries first in there, yeah, and then it's important to get the folders in your path in the right order so that things get loaded in the right order. Like you would want RVM or RVEnv to load before the system Ruby loads, right? So if you type Ruby, you want it to find it from the RVEnv shim before it finds it on the system user bin, wherever it is that's installed. Does that make sense?
No, I don't want to do that. I can't do that.
Yeah. Cool.
I have 8 pieces of it.
That's all I got, I guess.
Pieces. 1, 2, 3, 4, 5, 6, 7. No, you gobble those. Dad, I know, pretend those ones are here.
Okay, cool.